Okay, so I think we'll get started, and those who continue to join, we'll just pick them up as they come in. So welcome to our webinar on understanding the relationship between asset lifecycle and reliability tools and methods, presented by Doug Plucknette with Allied Reliability. So we thank him right from the start for taking the time to participate with us today. Just a little bit about UE Systems. We've been providing ultrasound solutions since 1973, so been around for quite some time now. We've got offices all over the globe to help support our customers with regional offices in the U.S., and you can see our international offices there. You'll also see us out and about at all kinds of different industry events within the reliability community. And this is just another way that we try to support the reliability community by offering these complimentary webinars on a monthly basis. And we also record all of the ones that we do, so we can put them up on the website so folks can access them after the fact. So just trying to continue to provide content and education, and we're thankful that we have folks like Allied Reliability that are willing to help us out with the content. You'll see here just a quick snapshot of our interactive information kit, and this is something that's a really great one-click tool that shows you everything that we offer, our different software, different products that we've got, and we're very happy to send this to anybody that wants a little bit more information, so you can contact us and we'll be happy to send this your way so you can learn a little bit more about what we're doing. So without further ado, I guess we'll welcome Doug Plucknette. And let me just pass over the screen, Doug, to you, and you will be all set.
Hello. So I am here. Let me just make sure I get this up to full screen. Okay. First of all, starting out, good morning, good evening, good afternoon, whatever it might happen to be for you. I'm going to do this presentation on understanding asset reliability. This is a presentation I put together a little while back, and I talked to folks at UE System. We thought it would be a good webinar. I'm a person that instructs basically a lot about reliability-centered maintenance and RCM Blitz. Been around the industry for about 15 years now, and I'm really getting just used to this webinar thing. It seems strange. I'm sure there's people probably walking down the corridor right now saying, what is that guy doing talking to his computer all by himself in that room there? So I'm sure that if you were here, there'd just be a thunderous applause. But at any rate, let's get started, and we'll get on with the presentation. Okay, trying to advance slides here. All right, most people are familiar with the PF curve, and this is a version that we use at Allied Reliability, GP Allied or Allied Reliability. It shows point P is the point in time where failure is first detected, point F is where an item functionally fails, and a lot of focus has been put on the PF curve through the years. In fact, I've heard at many conferences and presentations, boy, you should be focused on the PF curve and focus on point P. And, well, if point P is where failure can first be detected, well, it's already occurred, right? And I'm not saying we shouldn't focus on point P, because we need to know when potential failures occur, and we use predictive maintenance to do that, but there's a lot more in terms of reliability to what should be shown in the PF curve. The PF curve is going to introduce people to how components fail and the concept of the PF interval, which gives us many times a place to plan and schedule and do work once point P has been detected. And while the PF curve does an effective job at making that illustration, it only shows a portion of what an organization should focus on to achieve and sustain reliability. Thus, the need for the asset reliability curve. Forgive the pause there. I'm trying to figure out how to make that all my information about your webinar up in the corner disappears so I can see my full screen. At any rate, I can see most of it, and I'm quite familiar with what goes on here. This is the full asset reliability curve. Reliability really starts with design, right? So we have the design domain, and we want our people that are in our engineering organization to design an asset for a certain inherent level of reliability, right? And if we use the right tools and methods, which I'll get into as I describe the design phase, we should be able to achieve and design whatever piece of equipment is to a certain level of reliability. Then comes the proactive domain, and we'll get into the things that we can do there to ensure reliability. And that domain, our point should be at the time of installation, we want to ensure the longest interval between point I and point P, which is potential failure, is possible. And I'll discuss what are the tools and methods we can use there to improve that. Once we determine point P, we have that PF interval that most people are familiar with. What are the tools and methods we'd be using there? And then once we have functional failure, we have the reactive domain and the things that we can be doing there. If we look at that DIP interval, it's a visual of the different phases of the asset from the time we design it to the time it fails to perform its intended function, which is functional failure. The intent of the DIPF interval is to illustrate where we should focus our efforts and what techniques need to be applied to have the most impact on the overall reliability or life cycle of this component. Point D is the design phase. That's where the team is selected to procure or design a specific asset to a desired level of reliability. Point I is installation. Again, that's the point where the equipment is installed. I think it's important for people to recognize many cases, this is the point in time where we first upset the overall life of a piece of equipment or a component, is right at the point of installation. Point P is potential failure. It's the point in which a defect is first detected by an on-condition task or predictive maintenance technology. Point F is functional failure. That's the point in which the asset can no longer deliver its intended function. Remember, functional failure is a little bit different than totally failed. So we'll get into what that means and why we should focus some energy around that as well. Tools for improving reliability of the design domain. FMEA, this is going to look at, which is failure modes and effects analysis. This is going to look at high-level failure modes. What happens if this particular system or component fails, and what should we do in the design phase to eliminate those types of failures before we install them, right? So what is the best type of pump that we should use here? What is the best type of, what type of piping should we use? What grade, right? All those different types of things. How much support does it need? How much of a foundation should we put in? All those things that can be done at the design phase typically come out in FMEA. RCM Blitz can do the same thing. That's a reliability-centered maintenance tool. It looks at your failure modes at a deeper level, right, down to component and parts. And the value of that is at the design phase, we're not only going to find some of those flaws in the design that we can eliminate and design out, by the time we install it, we should already have a maintenance plan in place that once our equipment is installed and is up and running, we know what we're going to perform for maintenance. We don't wait for things to fail. We've got that complete maintenance strategy from the get-go. I've always said as a person, when I was in operations and maintenance, I would have loved to have just one time a piece of equipment delivered that had a complete maintenance strategy with it. So once it hit the floor and was running, we knew what PMs we should do. We knew what predictive maintenance tasks we were going to do, right? We knew what the operator checklist should look like. Most places wait for the equipment to be installed before they ever start talking about that. Design standards, right? Design standards get into, again, foundational issues. How much support do we need there? What type of base are we going to use? The piping, the supports, anything that has to do with how that equipment is put together if we design it to a specific standard and we create a standard with our company, we're not going to make those mistakes over and over again. I go from plant to plant and working for some of the same companies and see some of the same mistakes that they make over and over again, or even some drastic mistakes that they could have eliminated had they followed the design that one of the other plants had used. So figure out that best design and then use that as a design standard. Requirement documents. These are documents that you put together for the people that are building or manufacturing components for you. When I worked at Eastman Kodak Company, we did a large project on our tank farms, and before our pumps were even installed, we had Lightning sign off to the fact that when they did start up and run, they would be able to produce a specific amount of pressure, flow, and they would run within our vibration specifications as well. At this point in time, we should also be doing maintenance, reliability, foundational elements. This is developing your equipment hierarchy, criticality analysis, and bill of materials, so that, again, before this stuff even hits the floor, we have the ability to be able to say, all right, here's what we're going to order work orders against. Here's how we're going to track history. Here's the parts that we're going to have on hand. Here's the components that are critical to this piece of equipment. Right? All those things, if we don't put those foundational elements in before the design, we wait for something to happen, and then all of a sudden it's a crisis. Oh, where do we get that motor from? Gee, that's different from all the other motors we've ever installed here, right? So at that design domain, this is where all those things should be done and built into. From the design domain, why would we focus here? 2 words, life cycle cost, right? It's the inherent reliability of your asset is determined at the time of the design. It's of extreme importance to determine the required capability level of or the reliability required to meet or exceed capacity. The tools and methods listed above were designed to ensure that reliability and be both more cost effective and efficient when performed in the design phase. So it's all about life cycle if we do a good job in the design. If we don't take our time and use these tools and elements, it's going to impact the overall life of the equipment and the cost it's going to take to maintain it. I often tell people in that design phase, you might want to think about designing it at 20% above what you're expected to first run at, right? Because if the product is good and customer demand goes up, it's only human nature to say, let's run it faster, let's get more out of it. So design for that to occur. The proactive domain is known as the IP interval, and there are tools and techniques we're going to look to improve reliability at the time the equipment is installed. So before we install it and as we install it, what can we do? Reliability-centered maintenance. Identify what your failure modes are. Identify what tasks need to be done prior to doing that installation or at the time of installation. What are some of the things that could occur at the time of installation? Eliminate those failure modes before they can occur, or before they do occur, with things like precision alignment and balancing, torque specifications. Have all those things in place and have your people using them. I can't tell you how many plant sites I go to, and as I'm performing an RCM analysis, I begin talking about gasket or seal failures due to improper torque, and I ask, do you have a torque wrench? And somebody will say, well, we have one in the maintenance shop. And how many people work in that shop? Well, we've got 27. So one torque wrench for 27 people. How many things do you think are being torqued? Same thing goes with the companies that are installing the assets for you if you're not doing them themselves. I find the same thing. We have to have those things in place, the standards in place, and we need to make sure they're done at the time of installation. PDM benchmark data. If we have that at the time of installation, now we know what are the things we should be looking at, what are the tools we should be looking at, using what frequency or interval of inspection needs to be done. We can also use these tools to put together commissioning data at the time we install things to make sure things are precision aligned and balanced before we actually start up and begin making product, right? Preventive maintenance. All right, in this IP interval, we're doing both PDM and preventive maintenance tasks. If we have some wear-based items, what PMs need to be done to make sure that we continue to have the level of reliability that we designed into this asset. Why would we want to focus on the IP interview? Well, the inherent design reliability of your asset is determined at the time of the design, and it's ensured at the time of installation. So we could do a fantastic job of designing a piece of equipment, and we can have a negative impact on the reliability of that asset if we don't do a good job at the time of installation. And people see this quite frequently. You can take a fantastic pump like a Durco pump and just completely ruin it by not putting a good foundation or a good base underneath it, not supporting the pipes. It's that point in time that we ensure the inherent design of that asset. And if we don't do a good job at the time we install it and after it's been started, we don't do the correct PDM and PM task, it's going to have an impact on the IP interval. Corrective domain. This is also known as the PF interval. This is the one that most people are familiar with. Right? There are tools and techniques we're going to look to improve reliability and reduce consequences following the defect. Things like root cause analysis. Right? Are we seeing this over and over again? I recently worked with a customer that said, boy, we've got a new PDM program that's going on. Boy, we're saving ourselves a lot of money because we can detect the failures of this gearbox that we've had in the past. And when they've happened before, we used to have this downtime because it takes about 8 hours to get this gearbox out and about 8 hours to get it back in. And we didn't know it was going to fail. And then it would take some time. And in total, we were down over 24 hours. Now we've got the PDM program in place. We can detect the vibration, then we can plan and schedule, and now we can take that gearbox out and replace it in about 12 hours. So it saved us a bunch of time and money. Well, my question to them was, how often does that gearbox fail? And they said, well, you know, about every 6 months. Right? That's the point in time where, geez, if we got one item and it's failing that often, it's nice to detect that it's about to fail, but we want to eliminate that failure, right? And root cause would be a good tool if it's a single component like that to say, what's going on with that gearbox? Why are we having failures, right? Planning and scheduling. This is what we need to, where we need to get good at this. The PF interval is limited. We don't have an indefinite amount of time to plan and schedule this job. Once we can detect a bearing or a gearbox is on its way out, we have a limited amount of time. So we need to get good to make sure we understand this is all the things we need to put this job plan together to make sure we replace the component before it fails so we don't have extensive secondary damage to our equipment, right? And we're going to put it in a schedule and make sure that it gets done with a high priority on it. PM tools also work in this domain, even though many of the PDM guys get a little frustrated over this. Yeah, we can continue to monitor, even though we've detected point P, we may want to continue to monitor it to make sure and determine how quickly it's failing. It's certainly not going to give us to the day, week, or hour that the component is about to fail, but it can tell us how quickly it's beginning to go. Right? So it's really there to monitor fault progression to deal with your time constraints. This is also a place where we can develop consequence reduction techniques. Again, this goes right along with planning and scheduling to reduce the mean time to restore, because once you have hit point P, the item is going to fail. So what can we do now to reduce the consequences? Why would we want to focus our efforts here? Well, detection of potential failures, point P, gives us time to plan, schedule, and execute the corrective maintenance in a way that significantly reduces the cost incurred when we run our assets to failure. All right, root cause analysis, again, is going to help us to identify and eliminate the causes, and then On the other side of this, improve the IP interval, right? RCM also does that, and that's really where we should be focusing most of our efforts. How do we get the longest time between the point of installation and the point of potential failure? And to give you an idea of what I've seen in the past on cases like this with one particular company, they had a pump, the pump product from one set of tanks to bottling, right? And they had an MTBF of 18 months on these pumps. By focusing on design and installation, we made some changes to those. That was in the year of 2002. Those pumps are still in service today. So from 18 months to over 10 years, by focusing on what does a proper pump installation look like, what's the foundation we should be using, what type of base should we be using, what type of alignment do we need to maintain between the pump and the motor, what type of support do we need with the piping. By addressing all those issues, designing a good design and installing these things correctly, we changed that MTBF from 18 months to over 10 years. And that wasn't on a single pump, by the way. That was at multiple locations. This was an issue for them. It's a few different sites because at the time they installed these things, they just didn't understand the value of what a good design can do for asset life cycle. The last interval is the reactive domain. So what do we do here? Right? We shut down our equipment or run it to failure. You make the decision. Regardless, you're going to have to open your checkbook, cross your fingers, and hope it doesn't happen again. If you haven't identified the failure mode that caused it and understood that failure mode, figured out how to eliminate it or detect it, it's going to happen again. If you focus your efforts here, maintenance costs are going to continue to rise and assets will not be reliable. Right? The ability to plan, manufacture, and deliver customer orders is going to be impacted. Now the amazing thing is most of the companies that we do work with, they focus all their efforts in that reactive domain. They try to learn how we're going to do things faster. We need more parts on the shelf, right? We need to make sure we install a great big come-along over the top of that, and we'll just leave it in place so that when we pull that gearbox the next time, the come-along's already there. That'll save us 20 minutes, right? All types of things like that happen, and it amazes me, right? Go back the other way on that PF curve. Focus your efforts up front. Start with design. Use those tools. Use the experience of your people to understand the failure modes and design these things out, right? Once we understand, again, the failure modes, what's the correct maintenance, and then do a great job of installation, and we should have a nice, long IP interval. All right, that went a little bit quicker than I thought, but questions or comments? Maureen, is this where you take over again?
Yes. So if anybody has questions, there's a questions box in your panel that you can type them in. But in the meantime, Doug, just a question, for folks that aren't at the beginning of the stage but trying to find their way in the middle, what's your best advice for kind of picking up, not being able to start at the design phase, but they've got the equipment's already there and they're in this reactive environment? What's like the best way to start getting out of that reactive?
All right. Am I?
Yeah, you're still on.
I just want to make sure. Yeah, we're not getting that echo. Are we okay, I think? So anyway, if you're not in that phase, that's really what most of my business is dealing with companies that, just like you said, they're in the middle there. They don't have a good long IP interval. They're suffering from breakdowns and failures. And RCM is a fantastic tool to help to address that. If in that case, what we do is we talk about what are the things that are occurring at your site, right, and what can we do to identify those failure modes and eliminate those failures, right? Now, eliminate those failures. Some of them may be just as simple as procedural redesigns, but in reality, the big impact comes from building a complete maintenance strategy. Most companies don't have, again, a good maintenance plan for how to maintain their assets for reliability. Right? They're going and dealing with things on a day-to-day basis. We can help with that through developing good on-condition or predictive maintenance tasks, good PMs, all right, so that can eliminate several of these failures. Job plans are another way, right? Eliminate job plans. Every time we do maintenance, we risk putting infant mortality back into each and every device by making mistakes, right? So job plans are the way to work around and get away from having those occur.
Okay, great. And I did
Other
have
questions?
Yep, I had a question come in. Back to the design phase, one of the elements you were talking about was the select supplier agreements, and just someone wanted a little bit more clarification on that and why they're so important and how to really best practices for going about setting those up.
Yeah, select supplier agreements help in a couple of ways. One is we want to look for a supplier that has a reputation for supplying reliable parts and components, right? So the other advantage to that is inventory. I work with many companies that there's a lot of pressure to reduce their inventory, right? Spare parts. The reason why they have that is they might have 12 different brands of motors at their facility, right? In reality, what they should have done to begin with, and that they still can do, but it takes a little more time and effort, is to say, what are the 2 or 3 that really work for us, that have proven performance, right? That can get us a motor when we detect that one is going bad, whether with vibration analysis or motor current analysis, that can deliver us that motor when we plan and schedule, right? So it's very important to have those select supplier agreements up front. Work with people that have a reputation for reliability and providing reliable components.
Okay, great. And another one that came in, how do you recommend or suggest for the maintenance folks out there to get management to let them into the design phase, to really let them be a part of that process? What are some best tips for those folks to get their foot in the door?
Well, that's always, I always tell people that's one of the toughest cultural nuts to break, right? I can remember working with one specific company that brought me in to do an RCM in the design phase, and it was almost intimidating for the design engineers to have the maintenance folks in the room. All right, now in that case, they're already there. So how do I get them in there if they're not there? That comes with the maintenance guys being disciplined enough that after they get a new piece of equipment to actually sit down, right, and make a list of the items that they think, gee, you know, if we'd done this in the design phase, if we'd put access to get in there to be able to maintain this, if we had put a better foundation into that, I can already see it's learning about those things as you gain experience to say, I can see at this point in time there's already mistakes, and pointing that out to the engineering group and to your managers to say, look, we're valuable. We need to be there in that phase of the project because we understand what it takes to maintain the asset.
Okay, and another one, so for those folks who, you know, they haven't experienced a recent failure, and yet this the RCM process being so valuable, how did those folks go about convincing management to put up the money to do an RCM when they haven't had a failure recently, to kind of have that pain to convince management to go through that process?
Yeah, I always say the easiest way to get people to do it, convince people to do an RCM is to do it on a critical asset that where we have had failures. So when somebody hasn't had a failure, it comes down to then it's an educational process, right? It's going out and learning more about RCM and the value of it in any phase, whether you're doing it in the design phase or for an existing piece of equipment, right? Just because something hasn't failed doesn't mean that it won't fail or couldn't fail, right? We need to understand what those potential failure modes are and address those. And I've yet to do an RCM, and I've done hundreds of them, where we didn't find several failure modes that the company was working with hadn't considered, right? So there's always a value in doing that. It really comes from education. I would tell people, buy your manager my book and have him read it, right? Let him think at that point in time, once he's finished, is this something that we should be using?
All right, and nice plug there. Did another question that came through, did the big increase in pump mean time between failure come only from better installation, or were maintenance practices also improved?
Well, it was twofold, right? Because, if we hadn't improved the installation, that probably had the largest impact on the mean time between failure, but it also gave them a point in time where they could now start using some of the predictive tools that actually work, right? It also was a point in time where they could use some of the proactive tools like precision alignment. This particular company had tried precision alignment on many, many, many occasions, to the point where the maintenance guys, it's not, they said, well, we can precision align the pump that's there, but 2 weeks later it'll be out of alignment. The precision alignment stuff doesn't work. It helps, initially, but it's not going to hold, right? Once you have a good design, now we can do, and that's a maintenance guy is going to be replacing that pump. Now they understand the importance of alignment and balancing, support, all those things, because it's shown. So for the other places of their plant where they've got pump installations, now they see that. They're having to maintain those other assets as well, and they understand the importance of how doing their job in a precise way impacts reliability.
Great. Actually, there's lots of them here, so I'm glad we've got some extra time. What would you advise for using emerging technology where there's no prior experience or minimum experience?
I always say that when you're about considering doing something new, it really takes a person that wants to stand behind that technology and prove it out. So more than anything, it comes from personal drive, right? Giving your tool a plug, Maureen, I was at a site in Louisiana a couple of years back, and trying to convince the team that they needed to use ultrasound to address several failure modes that they were having at their site. And they said, well, we'd like to do that, and in fact we have an ultrasound gun, but it doesn't work because we've got so many other things going on here, right? Well, it turns out the gun worked perfectly. It had at one point been taken out of the box, right? But it took, again, leading them out there, showing them how the tool works, and then 2 people out of that group that became excited about that, and then they drove that program from there. So all it really takes is a couple individuals that believe in something and see the value in something. Once they did that, it was an easy sell for their management to say, yeah, we should be using this in a lot of other locations or for a lot of other failure modes, because now they're actually using it and showing the benefits of it.
Great. And another question that's kind of around the predictive tools. So what advice do you give to someone who has the tools, these predictive technologies, and yet they're still in this reactive mode? They've invested the money, but they just can't get their arms around getting out of that reactive mode.
What that comes down to, Maureen, is money, or whoever wrote that question, because this is a question that comes up quite frequently. Yeah, we're using vibration analysis, but our managers never respond to it. We'll tell them that something, we've detected point P, but then they still run it all the way to failure, right? We need to start showing what that costs to do that, right? Because if you run a gearbox to failure, typically you're going to tear it up and you're going to have to rebuild the entire thing. And the cost of doing that is going to be significantly higher than if we replaced it at the point in time where point P was first detected. So we've got to get that first one that's at point P where we can say the difference is $2,000, $3,000, whatever that is. We need to be able to show people what that return on investment is, right? It's hard to tell people, gee, you know, if you're not going to respond to those things, why are you doing the technology to begin with, right? So it really comes down to building that business case to say, look, we're not doing this because it's nice to do. We're doing it because there's a benefit. Show the benefit.
Great, and there have been a few requests if you would be willing on your slide deck to go back to that first slide with the graph on it. If you could show that chart again, some folks just wanted to see that up there. And in the meantime, there are a few more questions. Seem to be quite a few around that first design phase. There's quite a lot of conversation going on here. So another one that I've seen, someone's wondering, so manufacturers of equipment aren't necessarily going to be aware of how that equipment's going to be used once they sell it to you. So what are some best practices for getting those manufacturers involved in the design phase when they don't they might not necessarily understand the way you're going to utilize it?
Yeah, getting the manufacturer involved in the design phase is difficult. It really comes down to your engineering group knowing what the best products are for the service that you're in, or the service that you're going to have that device in, and then finding manufacturers that match that. You know, I can tell you that in the chemical business, we only dealt with manufacturers that provided instruments, controls, components for the chemical industry, right? Because we knew they were built for that. I wish there was an easier, better answer than that, but it really comes down to that's the responsibility of your own engineering community to find the manufacturers that make components that are designed for your operational environment.
Just trying
Any other
to.
questions?
There are. Let's just do maybe one or two more, and then we'll let everybody get back to work for the day. Someone was just wondering if you could explain a little bit more the difference, or maybe that's not necessarily a difference, but the relationship between RCM and predictive maintenance.
Okay, reliability center maintenance is a reliability tool, right? And what that does is it looks to develop or discover all failure modes, right? Predictive maintenance is a tool that's used to discover or detect potential failures or potential failure conditions, things like heat, noise, vibration, current faults, those types of things. So RCM looks to say, how do we get the correct balance of maintenance? How much of it should be PDM? How much should be PM? How much should be failure finding task, operational or operating checklist or daily checks? So it really develops that complete maintenance strategy. That's really where it differs from predictive maintenance. Predictive maintenance is really used to address a specific failure mode. RCM is designed to discover the failure modes.
All right, great. Well, there's still quite a bit of discussion going on, but I think what we'll do for everybody out there that maybe didn't get their question answered, we'll be sure to get those questions over to Doug to get answers to you. But I really encourage, for those of you that are already in our UltraProbe users LinkedIn group, to continue this conversation and the great dialogue that Doug's presentation has started for us in that forum, so that everybody can kind of continue to learn and keep the conversations going after this is over. And those of you who are not a part of that users group on LinkedIn to certainly join. It's just another great place to continue to ask questions, get answers, help answer questions, just a good networking opportunity there, especially with the dialogues that I've already seen going on. So I'm just going to take this back over from you, Doug, And just a couple more
All right.
slides before we wrap up. And Doug, obviously, thank you so much. That was a great presentation. You obviously stirred up quite a bit of questions and comments, so that was great and very useful information that I'm sure you know, we'll be able to keep building on and maybe even have a whole session one time on just that design phase, because that did seem to stir up the most discussion there. So thank you. And
You're welcome. Thank you as well. I am going to sign off because I actually am teaching today.
That's
in fact,
right.
I kind of remembered that phase of my RCM course just before we did this. So,
there you go. That's right. Doug was able to join us from an actual site where he's doing an RCM. So you're right. Thank you, Doug. And we'll be sure to get your information out to everybody and information about the different ways that you can help folks along their path here towards reliable processes. Okay. So have a good rest of the day. And for everybody else, we'll just run through just a couple more slides here just so everybody knows. We've got a ton of useful information on our website, uesystems.com. And one thing that we will be adding to the website here either today or over the next couple of days as we get it ready is the recording of this webinar. So you'll be able to take a look at it again or share that link with any of your colleagues who might not have been able to join us today so that you can take a look at it, and also all of our old webinars that we've been doing these for about a year now. So there's just a ton of great information on our website. And you can see we've also got training courses that are in person, so we don't just do these webinars. We have certification courses, our Steam Trapped Examiner course. We've got a few of those coming up this fall, and that list of all of those is on our website as well. Also, as I already mentioned with LinkedIn, we'd love for everybody to stay connected, keep connected. It's just a great way for everybody to continue to use each other as resources. Like I said, we have our users group on LinkedIn. We're also on Twitter, and we have our Sound Advice blog. So we hope you check those things out, just more ways to try and keep everybody looped in. And save the dates. We've got our next webinar coming up October 2nd, and we're going to have Swagelok Energy Advisors doing a presentation on steam as we're getting into the steamy season, I suppose. November 7th, we've got Doug's colleague, Andy Page, coming back to do Bearing Failure Mechanisms Part 2, Failure Propagation and PDM Technologies. So that's building on the webinar he did for us back in March, I believe, which you can view on the website. And then our Ultrasound World 9, we're going to be May 6th through 10 next year in sunny Clearwater Beach, Florida. So get that on your calendars and make plans to join us there. And again, as I said, our training calendar up on our website, uesystems.com. And with that, I'll leave our contact info up here. Again, we will be recording, or we have been recording this webinar. We will put it up on the website and make it available to everybody, and we'll send you all an email when that webinar is up and available for you all to view. So don't worry, we will get that. And those other questions that didn't get answered, we'll get those to Doug and get you all answers, okay? So everybody have a great rest of the day, and we'll leave this up here a little bit. But enjoy the rest of your day and be safe and reliable.